Welcome to episode 3 of the Cloud Native Podcast. Today we talk about Cloud Native Fight Club, containers versus jails, CHroot, VMs, and zones. Welcome everyone to the Cloud Native Podcast. I'm Matt Farina, an engineer at Hewlett-Packard Enterprise, and with me is Matt Butcher, a developer over at Deis. Welcome, Matt.
Yeah, thanks.
And so today, the first thing we talk about in the Cloud Native podcast is we talk about the developer's toolkit. One of the things that we like to share is tools, techniques, tips, things that can help developers build stuff effectively. And so today, Matt, you had a tool that you wanted to share.
Yeah, so a friend of mine and coworker, Adam Reese, shared a fun little command line client. I don't know about you, but I spend vast amounts of my day working on GitHub stuff. And most of my GitHub stuff is organized in the GitHub issue queue. And Adam pointed me toward this tool called GHI, which is the GitHub Issues CLI tool. And using this tool, you can CD into your regular GitHub repo. And along with Git commands, you can run GHI commands. You can list the issues that are out there. You can edit the issues. You can tag them. I've been using them lately to track which things have been merged into which branch by tagging things and labeling things. It's just a fun, easy to use colorful command line tool that makes my life a little more pleasant than clicking around my way through the GitHub web interface.
You know, for those of us who have projects on GitHub and we have to be project managers of those things, it sounds like a good way to help us do that while still getting to play in terminal and not necessarily being in a user interface that feels close to, actually building stuff, which we're already doing, right?
Yeah, it makes it really easy to do stuff like, I'm working on an issue. I want to quickly see what the description of that bug was, and I can call that up in the terminal and go right back to editing. It's tools like that I like because, they just streamline my workflow just a little bit more.
Yeah. All right. Well, thanks, Matt, for sharing. I hope others find that useful. So today we're going to do Cloud Native Fight Club, and it's the first of a multi-part series where we dig into cloud native things. Containers, Docker, orchestration, all these things we'll be doing over the coming weeks. And we're starting off with Cloud Native Fight Club of containers versus jails, CHroot, VMs, and zones. To talk about what the heck are these things, why do they matter, and how did we get to where we're at with this low-level technology, and some of it's just changing the way we do things now.
Yeah, that's right. I think for a long time we lived in sort of the same world, and then all of a sudden things seem to have gotten very complex very fast. And so we wanted to take a moment to step back and say, what's beneath Docker? What's beneath OpenStack? And how did we get here technologically? And sort of what's the heritage of a lot of these things? And then, take a moment to ask, are we making the right decisions, right? Are we following a reasonable path forward? So this ought to be a fun way to educate ourselves a little bit, huh?
Yeah, hopefully. It was fun to read up on it. When we first decided to do this episode, we started making up lists of stuff and we went, wow, we need to do a little bit of reading before we sit down and do this. There may be a little bit more to this than just off the top of our heads doing it. And so this is nice to have a good start to carve this out. So let's bring on the Fight Club.
Yeah.
So let's start back with maybe the old days. And old days is fun because, we're not talking prior to us being born or anything when we talk about the old days, and we're not near retirement age or anything. And so with the old days, we have multi-tenant Unix. You can think of it maybe as shared hosting clusters, right? For those of us who remember the days of traditional old shared hosting, although I think a certain amount of that's still around and we're just not using it. So let's talk a little bit about this multi-tenant Unix and where that came from. Can you talk a little bit about that?
Yeah, sure. Yeah. The funny thing is that Matt Farina and I first started working together at Palantir.net, where we actually shared one big Unix box that sat in the closet, and we all had our separate development environments, and we shared the same database that was also on said giant Unix server in the closet, and we worked that way, right? And really, that was for me. So that was maybe 2009 or so. And I'd been working in roughly that workflow for about probably 10 years or longer, on and off, since I was studying computer science. And the idea was you create a Unix system and everybody gets their own login on the system, and whoever's the sysadmin sets everything up so that each user has their own, home/whatever directory. And inside there, we each kind of had our own little workspace. But of course, the problem was we were really all sharing the same resource pool. So any system level component, a web server or a database or whatever, anything that had to run as PID1 or as the root user, or that we needed to share access to, really, for the most part, was also something we couldn't touch, or somebody would have to give us sudo rights to do something. So there was a lot of finagling, I guess is the word I want to use, right? Because we all had to figure out how we're going to work together in this particular environment while keeping our own little workspaces separate, but sharing some of the bigger resources and only using root when we really needed to use root. Did I miss anything? Anything you want to add to that?
I think the only interesting thing about that was the experience, right? As developers, those of us working on the same projects and jumping around in an apartment and seeing what other people were doing and reviewing their code and poking around, because so much of it was shared and accessible for a development environment. I mean, you wouldn't want this in production. There was actually a really simple user experience to navigate that. And it's amazing how much work today we put into how do we restore that simple user experience of being able to poke at the other bits of code that we're sharing and working on with coworkers. When back then it was really simple. I just went up a directory level, knew the directory for the handle of somebody else who was in there, and I could poke around and see what was going on, what they were working on.
Yeah, but I don't know about you, but I remember getting emails at like 11 p.m. at night that were blasted out to everybody on my team at WebMD, because we'd used this workflow at WebMD years and years and years ago. And the email would say something like, would whoever left their Emacs editor running with screen please log in and shut it off because it's using all the memory.
Yeah. I never got those, thank goodness.
But you pointed out something earlier that we didn't talk about, which is that ISPs often used to run this way. Did you run an ISP in this particular configuration? Or work at an ISP, not run one.
Maybe I worked at an ISP that did a fair amount of things this way, because it was simple and it was easy. If you weren't going to do dedicated servers for something, and a lot of times we did dedicated servers or multiple dedicated servers and clusters. Reminds me of Beowulf clusters back in the day. But if you weren't, and it was just common shared environments, we did a fair amount of this, yeah.
And I remember when I went shopping to set up my own website the first time, I ended up setting it up on a system that was a shared hosting environment, but they used a different level. That one at the time used a CHroot environment, a changed root environment.
Yeah. CHroot kind of adds that next level of security to everything. It's not just I can wander around the whole system, but you're actually locked down with directory permissions to a specific place within the file system. So you don't have that freedom to go crazy. And so it added in that security layer, because you're not going to run a multi-tenant customer installation with different customers on the same system when they can poke around at each other. And that's where things like CHroot came into play.
Yeah, and I guess my main experiences with CHroot were that, and also with development environments. For a long time, I worked on Gentoo, and this was back in the days when, to really use Gentoo and to do it right, you might actually spend some time building yourself your own initial file system, right? So you might be mounting a file system and then switching into it, CHrooting into that, so that you had sort of your local copy of the tools, and then you might compile a kernel or reconfigure your bootloader or set up libc, and then switch back out of that environment and tar it all up, and then you would use that as basically your boot volume. So that's probably where it came from initially. I'm guessing that would be its initial design, but I think it kind of hit some limitations when it came to applying that particular model and using that to share multi-tenant systems. So what are, another route for that was something like the BSD model, right?
Yeah, in BSD, what they used jails, and jails was kind of, I mean, it built on that same CHroot idea of how do you segment things off, lock down the file system. Now, eventually, they added things, at the network level. It's not true segmentation there's a certain amount of aliasing going on, but it was that same idea of how do you start to break the system up, have different processes running in there, while not being able to see each other. And well, I can't remember the exact details. I think jails was locked down more than a CHroot environment ever was, all the way down to the kernel level. But I can't remember the details of what went in where, because jails back in FreeBSD, that was there in the 4 dot whatever releases of BSD back in, was that the late 90s? It's been a long time.
A
Something
long
like
time.
that.
Yeah, and and BSD definitely had an advantage because of its microkernel architecture. They could do things, they could share resources in ways that were maybe a little easier than Linux, and we'll probably cycle back to that one a little later.
Yeah, I mean, jails weren't the only ones that weren't the only other Unix-based system that were out there. BSD wasn't the only one looking to solve this problem. We also had things like Solaris and what Solaris did, right?
Yeah, I remember the day that I found out about Solaris, zones and containers, because I was at, you guys all know, we were all Drupal developers for a while together. And this was even before Matt and I met. I was at a DrupalCon in Boston, and I was kind of trying to pick a session. It was late in the afternoon, and there was one that I thought about going to, and I walked in the back door, and the session was packed. There were no seats. There were people standing in the back. So I went, I'll go in the one next door. So I walked into this almost completely empty room. And this poor guy at the front from Sun Microsystems is doing this little demo called An Introduction to Zones and Containers or something like that. And he was even giving away, CDs of all of this and everything. And so I jumped in, I sat down and I started listening to this. And once I started listening, when you're in an audience of like 4 to 6, you start thinking, well, I can't leave now because I have to stand up and walk past all these people and the poor speaker is going to be totally demoralized. So I stayed, and then I started listening to what he was saying, and he's explaining this system where developers could share. At the time, these Sun workstations could be very, very powerful compared to all the other stuff we were using. And he was talking about how we could share this environment by setting up a zone. And you could share a zone between multiple developers, or each developer could have their own, and they could start up containers in there, and they could be running all of their own services. So they could be running their own Apache instance and running it so that Apache is perfectly happy binding to low ports because it thinks it's running as root and so on. Whereas what's actually happening is the base operating system is managing all of this stuff in a very creative way. And at the time, most of this, the vast majority of it, went over my head. But I remember thinking, what a curious idea. I could be running multiple instances of file systems on the same system. I wonder why anybody would ever do that. And I sat through the whole session, and I walked out, and I remembered it, apparently, but it never changed my life. I think I might have installed Solaris, but given up before I had even gotten to the zones configuration. But then, looking back, I believe Joyent is still using this same setup for Smart OS, I think is what they're calling their branded version of what was then Solaris.
Yeah, and Joyent now owned by Samsung, if I remember right.
But really, I mean, while zones made a fairly small splash in my sort of cognitive life at the time, what did make a bigger one was when we got around to the virtual machine stuff.
Yeah, and virtual machines, it's that same idea of separation, right? But it's doing it at a different level. A lot of what we've just been talking about is segmenting the file system and then maybe getting into how the kernel is handling things. With virtual machines, you actually create a kind of a mock hardware environment and then literally run another kernel, an operating system, and everything in there that interfaces to, stubbed out mocked hardware that then talks down. So you create a fake physical layer for that separation. And virtual machines have driven just so much change in the way we do hardware, in the way we separate things. That's really, don't you think, the place that the separation took off?
I think so. I mean, the breakout technology for virtual machines had to have been AWS, right? When all of a sudden somebody went, wait a minute, we can commercialize it and make it possible to set up these, virtual machines, these entire operating systems on behalf of customers, and then we can manage them and start to free up their resources, so they don't have to worry about managing a physical data center worth of servers.
Yeah, I'm actually going to say it wasn't even AWS that did this. I mean, I was using VPS hosts back 2002, 2003. Even before AWS put an API on it, I could go request VMs with a web form. In fact, I switched a lot of my personal hosting from shared hosting over to VPSs, where I'd run my own mail server. I would do all these things myself, things that I probably shouldn't have been doing myself, but I was doing myself because I could, using VMs.
What about desktop wise? Can you think of when VMs entered your lexicon as sort of like a client side tool?
Yeah, it was actually probably doing web development when I needed an environment to run and build separate websites in. When I was when we were dealing with things like multiple customers, and we might have had a shared work environment, but darn it, I needed an environment in my home, was working remotely, not in an office. And so I needed to have that close because, I can't work on code in my home office and have the database be in an office building somewhere. That latency was so long. I mean, it made development, I just couldn't do it. And so I needed to have different environments and then keep customer stuff segmented separately. And to do that locally, that's when I really got into virtual machines. And this is a long time ago, before I was doing cloud computing and I thought about it mattering. A lot of it was, I'd pass it off to the customer or somebody else would deal with hosting it. But that's the kind of thing that I did. Does that sound familiar?
Yeah, actually, that's going to force me to backpedal, and I'm going to have to take back what I just said about AWS, because as soon as you said that, I went, oh no. Actually, I was running virtual machines long before that, because when I first switched to a Mac in 2000, I don't know, 6 or something, 7, I wanted to run some Windows stuff because work required it. And so I installed Parallels, and that was probably my first virtual machine that I ever really worked with. Yeah. And then I installed Linux on that, and it really was probably years before I started to think about it as a viable technology for making for streamlining the server environment. I think I was thinking about it at the time as a way to get away with running Windows inside of OS 10, or a way of running Linux inside of OS 10, and not appreciating. I didn't have the foresight to realize what a sea change that would cause when applied on the server side. So I'll take back all those nice things I said about AWS.
Yeah. Now that you say that, I actually ran Parallels back in the day before I did that too. So that's a good catch. I'd forgotten about that. But I'll say virtual machines actually drove change in a different way too. And that is at the hardware level. This is where it really gets interesting for me, because if you go look at modern hardware and computers, especially servers, there's a lot of specialty hardware to do virtual machines. So multiple virtual machines can have separate hardware. It's almost like hardware acceleration for this. That is physically separate to keep that separation that you need in a multi-tenant hardware system, but have that high performance. And they've even done things like you can have you'll have different hardware doing different things on the network card for that different VMs can then take advantage of. So you really do have that separation, not just in the kernel, not just in a mock layer, but even in the hardware that's doing things like your network communications.
And this is probably part of the reason why more security-minded people will point out that virtualization at that layer is often more secure than something in one of these other layers where you're actually sharing the same kernel and software space, right?
Yeah, and that's probably why when we get into containers and that, folks say you can't run a Coke or a Pepsi in the same container cluster or in some of these things because of that hard separation that's now become an expectation, that with VMs and the hardware you can actually get crazy separation that you can't do another way in the setups we have. And that's really a strong point for VMs in that separation.
Yeah, and you kind of surfaced something really interesting here, because we've just listed through a whole bunch of different techniques and technologies, right? And we started with when we're working together in a team and we just have different home directories on the same system. And here we are now talking about virtualization and running, potentially competitors on the same hardware. People who are competing everywhere out in the world could share the same hardware and not have concerns that maybe information is leaking from one to the other, or ideally shouldn't have concerns because there ideally shouldn't be, areas for concern. But of course, we know this is so far an imperfect science. But we could kind of revisit all the stuff we just talked about in terms of trust and say, the old shared tenancy model was really one in which you had to trust the majority of the people that were on the system and in at least some level, right? And CHroots and jails had a different level of trust, right? Jails in particular were designed so that, Matt and I could each run our own websites on the same shared host. But still, we were not trusted to be able to run different servers. And each time we kind of dive a little bit deeper, we're talking about giving more trust over to the person inside the container while also isolating users from each other, right?
Yeah, and this kind of gets back to your example earlier, right? When we were sharing the same server in an office. Well, that server was run by the company. We were all employees at the same company working on the same projects. But the cloud has changed things, right? Now you've got data centers all over the world operated by different companies where your company isn't the only folks on that hardware often. You're sharing hardware, you're in different places, different companies are doing it. And so the trust model down through the hardware and operating it has changed too.
Yeah. And that's why that's the value proposition behind Azure or AWS or even OpenStack, is that you should be able to abstract away the hardware layer, but still allow people to feel that full experience of ownership of their operating system.
Yeah. Yeah. So let's move on to the main event, because so far we've been talking about the one side of the verses. Let's talk about containers. Let's talk about what we think of as in containers. And granted, this is a name. It's really maybe a code word for something else in Linux land.
Yeah, I think we're really talking about Linux containers here. And before anybody gets overly eager, we're going to try not to use words like Docker or Rocket or LXC or LXD today, because we think that they deserve their own fight club. But so let's skip from that. Let's talk about Linux containers, and then let's talk about the technologies that have really enabled this, right? So we were earlier talking about, kind of segmenting off bits of the file system. Okay, so first there's the home directory, then there's the CHroot thing, where really what we're talking about is how do we make it appear that you've got your own copy of the file system. But jails sort of start to introduce us to another idea, which is, well, maybe we can segment off all kinds of other things, right? Like we can say, okay, this particular network interface is going to appear in this particular way to the inside of the container, while outside the container, the host operating system will really see the world in its true colors, right? It'll know that there are 8 virtualized interfaces that are all mapping to the same Ethernet card or so on, right? What the foundational technology behind Linux containers really can be summed up in two words: C groups and namespaces. So namespaces are these, you've got this collection of tooling that can partition off things on the host system so that they appear inside of the container as isolated, while outside of the container, the host system can see them for what they really are. So imagine it, again, using the network card idea. I might have some number of Ethernet cards on the host system, but inside the container, I know the container needs to do some networking, so I expose a sort of virtual Ethernet device to it. And inside of that container, it sees that as its actual host Ethernet adapter. File system is another good example. Somewhere on this big file system, there's a segment of the file system that is mapped to what the container needs. The container sees it as its own root file system. Outside the container, It's just another resource attached to the same system. That's what namespaces give us, is this ability to take some names from outside and sort of remap them and reallocate for inside of the container. I know that's kind of a really quick simplification of it, but that's the basic idea. And then C groups are sort of the second step you need, right? Where you want to say, okay, in a normal system, we have the root user, and the root user starts the init process, and then all these other processes fork off of the init process. And you can imagine this as sort of a tree-shaped thing. So C groups are a different kind of tree structure, where you might say, imagine we wanted to group all of these particular processes together and treat them as a collection, an arbitrary collection. So, talking about a container, you start up a container, and then that container gets its parent, process, and all the other stuff is grouped together under that. And you can sort of see it in this tree shape, where you can say, all right, on the host system, I see that there are 9 different containers, and they each have this little slot in the C group. And underneath each of those containers, they have their own little tree of other processes. And what that allows you to do, and we'll skip getting into C groups and how they manage memory versus processing and stuff like that. But the important point is that a C group gives you a very real and manageable way to say, this little collection of processes is only allowed to use this many system resources. It's only allowed to consume this much memory as a whole. And if this container starts bumping up against the seams, we're going to say, oh, sorry, I can't use any more memory. So those are two foundational technologies that sort of coupled in the right way make it possible to do this little containerization thing, and yet do this all with like a vanilla Linux kernel.
Yeah, it's interesting. And for a little history, right? Containers, these C groups and namespaces, is actually a work that came out of Google like 11 years ago, 12 years ago now. So it's been a while. It came out of Google, and it was kind of one of the contributions they had, because, when you say, why did Google step in now into this new space that we're going to talk about in the next couple of weeks, you can actually see it traced back to how, when they went down this separation road, VMs, Linux, jails, and all of that, the path they chose and the path they chose to forge. And so they kind of gave us the foundation, I think, for what we're going to talk about in the next few weeks, because they've been doing it with their stuff for years. And it reminds me that, this foundational stuff that we've branded now with containers and these other names and all these technologies that have built upon that we're going to get into, it's really some core Linux kernel features that went in a long time ago that are at the heart of that.
Yep. And who would have thought that from those we would get the kind of thriving ecosystem we got today? And this is probably a good time to stop, because we've talked through several different technologies at this point. And it's probably a good time to stop and make the rather bland observation that of all the technologies we've just talked about, 2 seem to have emerged really more as winners, right? On the one hand, we have virtual machines. On the other, we have Linux-based containers. Would you agree? Well, first, before I say that, do you agree or disagree with that?
Oh, yeah, I agree that those are kind of the 2 thriving. And it's interesting because VMs have been the thriving machine for quite a while. And when you need that hard separation, that's still what you'd use in a public cloud or a shared setting. But containers have become this new upstart, this challenger to the status quo that we're trying to navigate. It's the new thing. And those are the 2 popular. I would say, even though right now all the hotness is containers, it's the new pretty thing, VMs is still the dominant platform. But I think that's going to be called into question long term, and we'll talk more about that in a minute.
So if we were to put on our steampunk goggles and imagine the world as otherwise than it is, what do you think the future is for the good old-fashioned multi-tenancy, Unix world?
I think it's actually pretty healthy, sort of. So this multi-tenancy Unix world, the shared file system, you're still going to have a lot of, shops that use it because of its simplicity. Think back to when we worked at Palantir. It's not as easy to share those environments and poke at each other. And so you're going to have, because we're not taking away the number of developers. We're not saying, there's X number of developers and we're going to be shifting them between technologies. It turns out that this is a little bit of a growth space and a changing space. And so there are a lot of developers who are still going to continue that model, the multi-tenancy, the shared file system model. But there's going to be a lot of folks who change to VMs or have changed, and even those who will take on containers and containerization. And so I think all of these are going to thrive in their own spaces. Does that make
And
sense?
yeah, and you raise an interesting point in that the virtual machine model and the multi-tenant model don't necessarily collide in the same way that the container model and the multi-tenant model really tend to a little bit more. Because you still could virtualize a shared environment in a fairly meaningful way and actually get decent performance off of it. But is there anything that you think really catches your eye as being a possibility for true innovative growth in that area already? Or are you basically hedging and saying, well, it's a legacy or near legacy technology that's just going to hang on for a while because the current solution, the new shiny solution doesn't solve all of the existing use cases?
I think you're probably right. I think the truly shared system is slowly going to drift away as tooling and ease of use and developer experience and new developers come on and don't use that, while ones who are very comfortable with it retire, move on to other things. You'll see it naturally go the way many have gone before. But I think when it comes to multi-tenancy, this is where things get interesting because virtual machines are the true multi-tenant solution right now, where you've got multi-tenant networks, you've got multi-tenant, you could true multi-tenant down to the hardware where you could put a Coke and a Pepsi or as some folks like to say, a CIA and KGB next to each other on the same system, and they wouldn't know about each other so much. But I think you're going to start to see some of this true multi-tenancy, which is where containers, Linux containers, C groups, namespaces actually have a weak spot. I think we're going to get that stronger. In fact, you'll see things like Clear Linux from Intel, which is looking at how do you take that hardware that was designed for virtual machines to be multi-tenant and have this fast hardware performance, and then put that into a container world. In fact, some of the network cards that are out there, right? Because containers, you can pack these C groups and namespace things, you can pack more deeply onto the same hardware with higher density. And so now you're seeing things like network cards that were able to share between so many virtual machines, and they had so much hardware to do that. Now, because C group namespace-based containers can do more density, they're now having more of that same thing on there to handle more containers using the same network cards and have that hardware separation. And so I think we're going to see that true multi-tenancy that you have in VMs come to the container world, and that'll get more interesting as we go along, especially with shared file systems and whatnot. We'll have to wait and see, but it's interesting to me.
So the already blurry lines are just going to get blurrier until eventually we just converge again.
We'll just have to wait and see. We don't seem to have a consolidation of technology these days, more of a division. And we're seeing, new things crop up and become popular and then fill out with those features that people come to expect in mature systems.
Yeah. Yeah. So in this list that we just went through, I'm curious to know if you think any of these are sort of, I'm going to use the L word and say, are any of these clear losers? Did any of these technologies we talked about today, is their future over?
I think, okay, so you got the shared system like we talked about, and I don't think that one's truly dead for some companies and some situations that will just keep working. But some of these things like CHroot, it's kind of over because we've got newer things that maybe I think have replaced it. And I wouldn't use it to where, you and I did some R&D work with a CHrooted idea like 5 years ago now, something like that. And if I were going to do that again, I wouldn't use CHroot. It would be containers.
Yep.
Just straight up containers. I think that one's gone. I think then there's things like jails and Solaris zones. And here's the funny thing, right? You talked about SmartOS and zones. And what are they doing with SmartOS? They are mimicking the Linux API kernel and then taking some advantages that you get in zones. And so I think that kind of says that C groups and namespaces ended up winning that battle, but there are some benefits to zones that people want to have that aren't there yet. And so they've kind of shimmed that in the meantime. but the winner's in the interface, the winner's in the end user expectation, right? And so I think, that happened right there. And jails, I hear about it, but do you know anybody using it? I, I
No,
love
no.
FreeBSD. I'm a FreeBSD fan. I've long used FreeBSD and wanted it to succeed. And I know lots of places where it's in use today. But I can't really think of many of those places that are actually using jails. And I know people use it and love it, and I think that's fantastic. But a certain amount of this is in the popularity space. And for the things that we're doing with developers and cloud native, you never hear anybody invoke jails. And so I'm going to say that the winners kind of are VMs and C groups and namespaces just by the sheer number of people who use it in the vote. If you vote by your use, that's what won.
I think the death knell for many of these and I think the shared hosting environment is dead. I think that the 1990s run multiple websites on one giant mega Apache instance model, I think that's dead. And I think that's what sort of signaled the fading of CHroot and jails into the category of uninteresting. CHroot is always going to be around. I think not always. I suspect CHroot will retain a sort of prominent place in build systems like those used for kernels or low level libraries. But I think its space as a true multi-tenant user land tool faded away the day that AWS and Heroku and Engine Yard all came up with models that were a lot easier for people to use and feel good about than the old shared hosting environments.
Yeah. Okay, that makes sense. So what does all this mean for developers then, right? Because so we talked about winners and losers here a minute ago, and we said VMs, kind of C groups, namespaces, containers won. And when it comes to the term cloud native, when people think about that, I'm going to go out on a limb here and say that containers won that space and are really poised to become dominant in that way. Would you disagree with that?
No, I think if I were to try and categorize where VMs will be attractive versus where containers will be attractive in a sort of realistic way, like in the kind of along the lines that we all sort of resonate with, I would put virtual machines in the quote unquote enterprise computing space. Whereas I think containers will really be pervasive from, small to extra large enterprises, right? From the startup to the Fortune 10 companies. I think VMs will slowly get more and more relegated to special cases. That's what I would say.
And so with this kind of thing, what do you think this means for developers? When you think about this, because, cloud native and containers and the things we talk about, what does this mean for the devs at the end of the day who've got to go build their apps and run them in these environments?
Yeah, well, I mean, that's exactly the issue that this podcast ought to address, right? Because this is going to change the way that we develop stuff. In some ways, the way we've been developing has been largely based on some assumptions that were made in the 70s and 80s, and they're not going to hold as true today. The kinds of tool chains that we were developing only a few years ago are going to kind of sort of seem a little bit irrelevant to us. And on the flip side, there's some new things we're going to want to do to make our applications feel more cloud native. One of the weird ones is this is one of the biggest stumbling block for me when I dove into containers.
I almost caught you there. You almost said the D word. You almost said the D word.
Wait till next word.
Next week.
Hear the D word. When I first started with that whale-shaped container, was why am I only running one process per container? It seems like I should, this is me coming from my Linux and Mac background where I'm used to running dozens of processes, dozens of servers on the same host OS. And now Docker is saying, I did it. Almost made it without saying the D word. But, the prevailing wisdom was you only run one process, maybe with a couple supporting things when you absolutely have to, but one process. And that's a big change. That was a big change for me as an enterprise level developer.
Yeah. And I'll admit that one really caught me because when we were doing Cloud Foundry stuff, which was based on LXC under the hood when we talk about different kind of container technologies, and we'll get more into that next week. Because I dropped another, it's not the D word, it's the LXC word here.
Yeah, fine. No,
But we actually did multiple processes in a single container. And I remember doing that. In fact, we might have a cron run in the same container next to an application. And so you had some oddity there that you don't so much see in this modern C group namespace world as far as a pattern. And so what do you think? Do you think that's just a general pattern or something that's tightly coupled to the way we look at C groups and namespaces?
I tend to hear two I'm going to call them excuses for why things are done this way. The first one is it's good architectural practice, and this I think is very much smuggling in the idea of the microservice into the container world. That we really only want to be running one small thing per container to keep our services very nicely organized in small shoebox-sized manageable units. The second one I tend to hear, and this is, I suspect, the real origin of it, is that with systems like C groups and namespaces, C groups in particular, if you're running 5 different processes in a container and you start to hit that boundary where you're not allowed any more RAM usage or you're not allowed any more CPU usage, it's got to kill something. And your system's going to get relatively unpredictable if it has to pick one of 5 processes, and then you're stuck doing post-op going, all right, well, the killer killed something in here. Why is this thing not working anymore? Oh, the killer killed something. What did it kill? Well, it decided to kill the database instead of the cron job that's actually consuming all the resources. So those are kind of the 2 reasons I hear. Have you heard any others? Or
No, I haven't.
I do feel like that first one, this is good architectural practice, is the first one everybody says. But I suspect that the second one is probably the real true pragmatic reason why we really only want to have one process or one major process per container.
Yeah. And it kind of makes sense when we get into, in a couple episodes, when we get into how we're orchestrating things and moving them around. I think that model makes a lot more sense when we bring it up a couple levels and how we're using this stuff. So if you're still not sure about this, if we actually hang tight and dig into that, I think that's when it made more sense to me from a pragmatic level. So we're used to systems with from a developer standpoint, you go back to CHroot, you had system libraries and everybody used the same versions and there was version handling in this. What do you think all of this means for, say, shared libraries?
Oh man, and this is the killer difference to me, right? For years and years and years, it was drilled into my head that because I played the role of both, a software developer and in some cases of an operator or DevOps engineer. And in all these cases, it was drilled into my head. We've got to keep the shared libraries synchronized, right? When I install package X and package Y and they both dynamically load some .so, we have to make sure that we're dealing with the compatibility between these 2 shared objects. And that was a major pain point. And those of us who used things like Python and Perl back in the day where they would all write all their libraries to the same spot on the file system, it was often a struggle to try and make sure that all the different applications could sync up and use that same library. So there was, I have like decades of echoes in my ears of people saying, make sure you do it this way, make sure you do it this way. But that doesn't really seem all that relevant anymore, does it?
It doesn't, because when you get into the way we're doing things now, every container can have its own version of the shared library appropriate for that. And the little bit of extra disk space for if you've got, 2, 3, 4 different versions, disk space isn't an issue anymore. And so a lot of the patterns we used are now thrown out the window, and those problems, because of the way we're able to wrap things, they kind of go away.
Yeah, I mean, you even said it right there. Each one has its own shared library. What's the point of the shared library infrastructure anymore, right? Why not statically compile anything we can statically compile? Which I suspect is one of the reasons why one of our personal favorite programming languages has gained so much traction in this space.
Yeah, that's probably a great reason for the Go binary that talks directly to the kernel makes a lot of sense when you're talking portability, wrapping it in containers, shared libraries, all of that. Yeah.
Yeah. And what do you think about? I love bringing up Java. It's like my favorite whipping boy. What do you think about the future of Java and containers? Is the way we architect for containers sort of becoming? Is it playing to Java's strengths?
I would say no. But then again, there's Java container technologies that I just realized we didn't really dive into here, and we're probably out of time to dig into those things. But yeah, the way Java and the JVM will have, multiple um, applications sharing a JVM and reusing bits and doing that, it's kind of the inverse of what we're doing in containers. In fact, if you take Java and you stick it in a bunch of containers and then horizontally scale it, it may end up using a lot more system resources than if you vertically scaled that same one on the same hardware, just by the very nature of the way Java works. And so I'm curious to see what the Java developers and communities ultimately come to, because that kind of hurts.
Yeah, we need to talk about that in one of our future episodes because I think there's interesting stuff being done there. But it doesn't seem to be the ideal. It doesn't seem to be ideally coupled with this sort of Linux container model, or even in many ways with the virtual machine model. But this does, this talk about shared libraries brings up another point, which is that one of the advantages to having the multi-tenant operating system with lots of shared resources was that we could use other items in shared ways, right? We could use Unix pipes to send messages back and forth between two different applications. Well, now we're saying really only one app should run per container. Inter-process communication could be achieved all different sorts of ways in these machines. Are we basically throwing our hands in the air and saying, fine, from here on out, all inter-process communication is now inter-container communication, and that's done over TCP/IP? Or do you think that there's much of a future for a lot of those other technologies, or have we just ruled them out as losers at this point?
Sure, with microservices, we'll put a REST API on it and we'll make Node.js apps. And it sounds like JavaScript just rewrote inter-process communications and the Unix layer, doesn't it?
Pipe.js. It works for me. Yeah.
It might already exist, actually, quite frankly, because we've rewritten everything in JavaScript. But I do start to wonder where this is going to happen and what it's going to mean for performance. Because some of this, you're right, I think we are reinventing some of those wheels we have out there that worked well, but we're bringing them into a new paradigm. And there might be some questions we can talk about more in this podcast going forward that touch on some of these things from a practical nature, because I think there's the whole practical side. So on the crazy side here, what about the desktop or the mobile phone or your IoT device, your Nest thermostat or something else? Do we ever think we're going to have containers in these other places?
Oh man, I saw this really cool demo quite a while ago. Probably many of you have seen Jessie Frizzell's famous Docker demo where she runs different apps in containers, different GUI apps in containers. So you're looking at one desktop and 3 windows. But I saw another one that took that idea to a different extreme. And the demo basically had window decorations, right? So windows that were outlined in red were started by one particular runtime, and those outlined in blue were owned by another container. And the idea was you could have completely segmented off instances of this. So you might be running 2 completely segmented off versions of Chrome, where they are, each living in their own container, each blissfully unaware of the opposite. And the argument was, maybe the future of desktop apps will have each desktop app running in a container like that. Does that offer us some additional security, where we might be where Chrome or any desktop app might somehow be more resistant to attacks by virus writers or cross-application attacks where you can get privilege escalation by exploiting one app and then finding a hole in another app running on the same host and then, achieve an exploit that way.
Yeah, interesting. I hadn't thought about that way. I know one of the other places containers are now starting to be used is in CLIs. Right? You can ship a CLI and it can have a whole lot of dependencies. And so it brought in that dependency model. If I'm going to take all the dependencies, we might write our CLI in Python, but do we expect the operating system that they're going to install it on to have Python? is there a way we can wrap up a bunch more of these dependencies into a container and then somehow execute that container in the local environment? And maybe it's not, using the D word, but it's actually just hooking into those underlying things and being able to execute it with that sent environment separate from everything else. And then you don't have to worry about system dependencies because you shipped them. And now that disk space isn't usually a problem for us.
Yeah.
It's one of those things that maybe it makes sense to do that, because then you can say, you know what? Are they going to have Python 2.6, Python 2.7? Are they going to have Python 3 on there? You know what? I'm going to ship the version that I know works for my app and just make it work and transparent. And
And
so
I
that,
won't have to use RBN ever again.
yeah, and there you go, because you can start to ship things around. And so I think we're going to start seeing containers show up in a lot more places than just how we're developing our web apps and our API servers.
Yeah, but I do think that that model is predicated on three different conditions actually obtaining. And the first one is the ubiquity of a container runtime, right? We all have to be able to run. Otherwise, we're just pushing the problem down a layer, and we'll have to have 4 different container runtimes to run 4 different applications. The second one is that we will need a lot more space, because in this particular environment, you're talking about running potentially every Python app I have has its own complete Python runtime embedded with it. So it's going to take more space and probably more overhead runtime in some cases, because nothing's shared anymore. And the third one, which is directly related, is networking. We're basically getting to the point where we're assuming that the average user has access to a high-speed network that can pull down these images in the first place before they can run them. Now, that said, I think we actually are really headed that way on all 3 of them, or at least on 2 of the 3, and I hope on the container ubiquity as well.
Yeah, and that's one of those things we're gonna have to get into starting probably in the next episode. So, yeah, I think we're headed in that direction. So when we
I
talk about all this container stuff, and we really kind of ended a lot on the container stuff. Why did containers win? Why do you think we're headed down this ubiquity route where maybe 2 of the 3 or all 3 are going to win? What's the reason for that?
I'm going to give all my pretend answers first, because I think you and I know the real reason. Uh, the Linux kernel has achieved remarkably broad acceptance. And I think that the combination of C groups and namespaces and a vanilla Linux kernel, together maybe with the fact that Google did come out and say, look, we built this technology and we've been successfully running it in production at massive, massive scale for a long time. All of those things really started to tilt the scale toward them. So, you could contrast that with jails and zones. The big hindrance, the reason why BSD jails didn't take off at quite the same pace is because BSD acceptance didn't take off at the same pace. The reason that Solaris zones didn't take off is because Solaris, unfortunately, was on the decline when zones were introduced. So I think that part of it just happens to be the Linux kernel. Before we hit that big obvious one, what do you think?
I don't have any other good reason besides the D word. I'm going to say it, the D word.
The D word. That's
Docker.
the big obvious one. Yep.
It's
Why
Docker.
do you think Docker won? Why do you think Docker pushed it over the edge?
And it's going to be user experience. I mean, how many people have you ever heard of actually using C groups and namespaces themselves? How many folks have gone in and used the hooks to make that work? I
can count them on one finger.
Yeah, exactly. Not a lot of people did. But Docker, that's accessible. People can use Docker. It's a simple CLI. It's not hard. The models, the way we used to share things and pass tarballs around, that was made more easy. That just works more easily. And we even made passing images around simpler to do. And so it's that hiding. I love this idea that, and I credit Rob Pike with throwing this terrible idea at my head, or this great idea, and that is simplicity is the art of hiding complexity. And I think when I look at C groups and namespaces and how you deal with a file system and pass stuff around, that's hard. That's not something you can throw at any developer. But Docker hid that simplicity behind simple commands and a simple experience, and that made it accessible. And I think ultimately that's why we're talking a lot about containers now and not VMs.
Yeah, I am 100% behind you on that. Docker introduced a workable user experience to something that prior to that required vast amounts of domain knowledge. And now it's, Docker pull, Docker run, or Docker build, Docker push. We've got these small pneumatic bite-sized things that we can do that, the fact that many of us made it a long time into Docker usage without knowing anything at all about C groups and namespaces means that they won, right? They were successful in accomplishing what Rob Pike, credited there, right?
Yep. All right. And so this was just our first part in the series of Cloud Native Fight Club. We started at the bottom with containers, and we talked about containers, jails, CHroot, VM zones, all that stuff. And next week, we're going to go squarely at Docker. We're going to talk about it and what Docker is versus and what that means, because Docker was the start of it as I look at it. Docker brought that experience. But wow, things have changed since Docker got hot. And what does that mean? And who are they versus? And where do we go from here? And so we're going to jump on that one in the next episode of the Cloud Native Podcast. Thanks for coming, everyone, and listening.